screen if you want.
Okay, I'll share my screen.
Yes. Yeah, I can see it.
Okay. Um,
Okay, let's wait a few moments to let people join the stream, and then I'll introduce you.
okay.
In case there are any questions in the chat, do you want me to interrupt you, or do you prefer the questions to be at the end?
I think I would prefer the questions at the end.
Okay.
Yeah.
All right.
Can you share the link with me to the YouTube? This is being broadcasted to YouTube, right?
Yes. Yes. Let me. Okay.
Oh, thank you.
Yes, I sent it in the chat.
Okay.
Okay. Okay, let's wait a few more seconds.
Okay.
Okay, I think we can start now. I will introduce you now. Bueno,
Okay.
buenos días con todos. Bienvenidos a la charla, a la segunda charla del CLI Week de Cocoa. Esta vez démosle una fuerte bienvenida a Gokul Soumya. Am I pronouncing your name correctly, Soumya?
It's Soumya.
Soumya.
Yeah, Soumya.
Yeah. Gokul Soumya. Él es un estudiante de computación en la India y un contribuidor core de Helix. Así que démosle una fuerte bienvenida y disfruten de su charla. You can go ahead, Gokul. Yeah, you can start your presentation now.
I hope my screen is visible now.
Yes, it's visible.
Oh, okay. Thank you. So, I'm Gokul Soumya. I'm a very enthusiastic command line user, and I'm also the open source maintainer of a popular terminal text editor called Helix. So, very excited to be here. So, my talk is going to be about oxygenating CLIs and building text editors. So, let's get to it. So, I would like to talk a bit about why CLI tools are a bit cool and why building them um, is good. So the main reason is when building CLI tools, we tend to focus on the core functionality. For example, say we are designing a grep equivalent so that we can search text files. So when we are writing a CLI tool for grepping files, we'll be only be concentrating on the core functionality of searching the text files. We will not be bothered about how to display it to the user. All we can do is print it because it's in the terminal. We won't be bothered about what kind of UI to make. For example, in VS Code, if you search, you will get multiple results, and when you click them, you can go to the files. You don't have to bother about any of them. You can just focus on the core functionality. And another reason is you can use this CLI as a backend for multiple UIs. So an excellent example of this is the ripgrep tool, which is used in VS Code actually. So ripgrep is an alternative to grep, and it is a faster search imitation of grep, and it's written in Rust. So it's so good now that VS Code has adapted into their search interface. So when you use a multi-file search in the sidebar, it searches for multiple files for the input you give. It uses ripgrep under the hood. So ripgrep is simply a CLI tool, and they have used it as a backend for VS Code search. And another wonderful reason is that you can compose the tool you write with other CLI tools. So which means that you can use standard Unix mechanisms like piping and reading and writing to files, and they all compose very well. But if you have written a GUI, it would only work as a standalone tool. So those are some of the reasons for building CLI tools. Now, for the past few years, there's been a new trend that there are popping up new CLI tools that replace older versions. So like BAT is a better version of CAT, and ripgrep replaces grep, FD replaces find, then XR replaces LS, and Helix does not exactly replace them, but it's a reimagined version, if you could say. I'll showcase some of them here just to give a taste of how they look, though I'm sure that most of you are familiar with it. So the most stunning, so to say, example would be BAT. So say I had cat is a command to print the contents of a text file. So say I'm printing the README file. And it's just a simple command. It's just cat, it just prints the file, and all it does is it prints a line by line to the output. But if you use BAT, so BAT is a drop-in replacement for cat. And if you use BAT, it pages the output so that we can scroll it with at the arrow keys or J or K, and it puts line numbers, it puts headings, it syntax highlights the file. So this is the newer tools are more user friendly. They have more bells and whistles. And for example, this is the normal output of the command ls, and I have rewritten. I have aliased my ls to be to invoke the exa command. The exa is like a drop-in replacement for ls, but it has icons. As you can see here, it has icons, it has colors, and if I change a file somewhere here, as in if I change a file anywhere, it will show up icon so that file change is added, deleted. So these tools are a better replacement or a better version of their older commands, and this is a trend that we've been seeing for some time now. So what makes them great, in my opinion, is their superior user experience. So for all these commands that I've written here, ripgrep is faster than grep, and FD, for example, it takes away a lot of the craft of the find command, and it lets you focus on simply the command. So for example, if you wanted to find every single file which ends in the extension rs, this is the find command that you would have to write. So it's kind of an arcane invocation. So the dot here means that you have to find under the current directory. The iname means that you have to match with the name case insensitively, and then you have to give the globe pattern at the end. So, and if you execute the command, it lists out every file which ends in rs. But if you use the same command in fd, which is a replacement for find, so we have to provide this command. And by default, it ignores the files in your git ignore. So find doesn't do that, but FT does. It automatically ignores files in your git ignore, and it also executes a search using all the cores in your CPU. So if I do this, it executes really fast and it's colored.
Gokul,
So
can you?
hello.
We can see your screen. Can you maybe stop sharing and share it again?
Oh, sorry. Okay, I'll do it
Yeah, I
again.
think the bandwidth is a little weak. Yeah, there we see it. Thank you.
Oh, okay, okay.
Yeah, go on.
I think I think my connection is a bit flaky. Can you just ping me if it happens again?
Yeah, sure. I'll tell you when it happens.
Oh, okay. Thank you, thank you. So I hope you guys understood talking about find commands. This is how you execute the find command if you wanted to find all the RS Rust files that exist. This is the invocation, but this is the equivalent FT invocation, and it is faster and it has more features. So this is the trend that we've been seeing. So yeah, the focus is on superior user experience, and also another common thing among all these tools that I've listed here is that they're written in Rust. So okay, these tools being written in Rust does not have anything to do with them having superior user experience. So another tool is FCF. FCF, everybody must be familiar with FCF. It lets you fuzzy find through files. So if I type FCF here, it lists all the files under this directory and I can search for them interactively. That's the selling point of it. But FCF is written in Go, it's not written in Rust. So the point I'm trying to make is most of these tools, most of them have been written in Rust. Now, so I would like to point out some reasons why that might have come to be, why developers choose Rust to write CLI programs. So I've listed some of the reasons that I think are most impactful. So Rust has an awesome type system. So a type system means that it's very strict type system. So a type system is a type system enforces the types of your variables and your classes and so on and so forth. So for example, if we take Python, it's not strictly typed, it's duck typed. So which means that you can change the type of a variable as you please, as you wish, and it can change at runtime. So a type may change from string to int, and you might not even know that because you might have unintentionally assigned a variable of that type to this variable. But Rust has a very strict type system and it is very expressive also. So you can encode your business logic within the type system itself. What I mean by that is you can catch a lot of errors at compile time instead of runtime. So when you compile it, if your variable is not of the correct type, or if you unintentionally assign values to a variable, if you, for example, assign a double to an int, it shows up as a compile time error. And in the Rust community, there is an obsession with performance and correctness and moving checks to the compile time. What it means that in languages like C and C++, you have to manually manage memory. You have to call malloc and free. And because of this manual memory management, there pops up a lot of errors. You can double free error is a very common one, which you call free on a resource, you free it once, and then you accidentally free it again. And then there are dangling pointers in which you create a resource inside a function and then return a reference to that resource outside the function. So it could be cleaned up any time, but the caller doesn't know that. So the caller assumes that the variable is valid for the entire lifetime. And things like this pop up as memory errors. So Rust has this obsession, it's a borderline obsession with moving checks like these to the compile time. So if there is a possibility that you're double freeing a variable in your Rust program, the program simply won't compile. And eliminates a whole class of errors by moving a lot of things to compile time instead of runtime. So there are a lot of checks. The compiler makes sure that you're handling every case, every possibility. So for example, I'll come to the error handling, which is an excellent example of this. So Rust also has some indispensable libraries like Serde and Clap, which are examples. So Serde is like a serialization and deserialization framework. So for example, a very common task is to read input and then convert it into a structure and then manipulate that structure. For example, say you're making a HTTP request, and the content, the response of that HTTP request, assume that it's a JSON object, which is very common for APIs. So when you get that JSON object, so you have to deserialize that JSON object into the types of your language. So for example, if you're doing this in Python, there is a built-in JSON library. You can import it, and then you can deserialize the JSON string into the object, and then you will have to manually access the objects. But in Rust, you can use Serde. It's not compulsory, but everybody uses Serde because it is so convenient and it surfaces errors at compile time. So what Serde does is you have to define a model upfront. So you have to define how your JSON response will look like upfront, and you can think of it as defining a class and then defining the attributes as keys of a JSON dictionary. Keys of a JSON object. So you have to describe the shape of the JSON object upfront, and then the keys will be assigned to this class. So it makes everything much more easier. I wish I could show an example, but we have time constraints. So one of the other things that I absolutely love about Rust is the mandatory error handling and null handling. So this is one of the things that I talked about earlier, the obsession with moving text to compile time. So Rust does not have exceptions, it does not have null. And when I say it does not have exceptions, that does not mean that it cannot have errors. Errors can of course pop up, but you have to handle them like values. So in most other languages, errors are implemented as exceptions. So when an exception happens, the runtime throws an error and you have to catch it with the try catch block. And if you don't catch this error, it goes up the call stack. And if you don't catch it at all, the program crashes. The way this is implemented in Rust is, if a program can fail, you have to return a special type called result. So if the return type of your function is a result, it means that there's a possibility that your function might error out, which means that you have to explicitly handle the possibility of your function error. You cannot call a function and then assume that it's going to go in the happy path and that is just fine without errors, because return type itself, the return value itself will be a result type, and you cannot get the actual value from inside the function. You have to handle the error case also. So you're forced to handle the error case, which gets annoying at first, but it is a fantastic feature because it ensures that every single error in your program is handled, or at least delegated properly. And another feature is that Rust does not have null or none in Python, or null in Java and other languages. It does not have. It does have concept of nothingness, but it does not have null. So Rust instead has an option type. So what option does is, instead of the language having a null, which means that every variable or every type has actually two representations. So consider, for example, you have a variable in Python. It's a string. Now there is a possibility that that string can be none. None is Python's version of null. So there is a possibility that that string can be null. And you might have to check if that string is null at multiple places. So there is no way to declare that it can only be a string. So it might be a string, it can be also be null. But in Rust, if you want to express the idea that, okay, it can be one type or it can be nothing. It can be a string or it can be null. The only way to do that is to use an option type. So an option is like a wrapper type. What it does is it wraps your actual data in a data type called option. So it's pretty much like result. So what you have to do, so what you do is if a function returns an option, that means that there's a possibility that it returns an actual type or it can return null. And you are forced to handle both cases. There is no way out of it. You have to handle both cases. So these are some of the reasons which I think makes Rust a good fit for the CLI, because the CLI takes input and then acts on it and then produces output. That's all what a CLI usually does. And what all these features do in tandem is to make that whole process a lot easier, a lot more streamlined. It means that your program won't crash out of nowhere. You would know exactly from where an error originated, and you're forced to handle every error. There are no null errors, and you have awesome library support, which means if say you wanted to pass JSON or CSV or any other format, there are good libraries to do that, and they can do it very performantly also. So coming next to Helix. So Helix is a text editor. It's terminal based. It runs in the terminal like Vim. And I'm one of the maintainers of the project, though it's been some time since I contributed. So Helix is also a quote unquote part of these new tools. So Helix reimagines the way Vim works, or the way model editing works. So it has multiple cursors like Sublime Text, which is a really cool feature. I'll showcase some of these features here. And it also has some built-in features that we've come to take for granted in other editors. So I think it's best to showcase these features instead of talking about them. So Helix is installable via most package managers. I'll link to the GitHub page at the end. So the command is headchecks. The invocation command is called headchecks, and this is how it looks. I've changed a little bit of things like my theme, but for the most part, this is how it looks. Okay, for example, okay, so Helix is a model text editor. What that means is, it uses modes instead of a normal normal texting. So what you might have been used to VS Code, it's different from that. So it's more like Vim and Cocoon. Okay, so right now the text editor is in normal mode. As you can see here, it says normal mode. NOR stands for normal mode. So when I hit I, it goes into insert mode, and I can only insert text. I can only type text if it's in insert mode. And if I type escape, it goes into normal mode again. And this type of model editing takes some time to get used to. But after some time, you might find yourself to be more productive. In model editing, I like to use the word flow instead of being productive, which means you don't have to think about what you want to do. For example, if I wanted to select this whole enum, if I was using any other editor, I would have to take my mouse and put the cursor here and then select from here to here. But if I was doing the same thing in Helix or Vim or any other model, I would just I have to select this paragraph, and I would type 2 or 3 letters. In Helix, it is MAP, which is match around paragraph. So it selects the whole paragraph, and then if I press D, it deletes it, and if I press U, it undoes it, and if I press C, it deletes the whole thing and puts me in insert mode. So this is basically how a model text editor works, a basic introduction. Okay, so the selling points of Helix, some of them I've listed them here. So the main selling point of Helix is multiple cursors and the built-in features it offers. So multiple cursors is everywhere now. VS Code has it. Sublime Text introduced it. and I'll showcase them a bit. So say I wanted to select every invocation of, what's a good example for this? Okay. Say I wanted to select every single occurrence of the word use inside this selection. Or say I wanted to select every single invocation, occurrence of the word use in the entire file. So what you would how you would do this normally is to use the find and replace function in normal editors. So what I can do here is select the whole file, which has a predetermined keybind. If I hit percentage, it selects the whole file, and then if I press S for select, it pops up a small pop-up here, and then if I type use and enter, it puts a cursor in every single occurrence of the word use. So what this means is that I have a cursor on every single word of the word use, and I can do other operations on all of these occurrences. So if I select the word and hit D, it deletes the word use, and if I press U, it undoes it every single place. So this is much more interactive and much more easy to use than other features like macros and Vim. Helix also does support macros, but it's much more easier to use multiple cursors because it's more interactive. And some other features are, and these are some of the features I like a lot. So Helix has a fuzzy finder. A fuzzy finder is like pressing Control P in VS Code, which means you get a pop-up of every single file inside your directory. So I just hit space F, and it lists out every single file, and I can interactively select files. I can search for them, I can open them, I can open them in splits, I can open them in new tabs, any which way you want. So, and it has a lot of other kind of fuzzy finders. For
Sorry,
example,
cool. Can you please try sharing your screen again?
okay. One second. Is it visible now?
Do you have an empty buffer?
Sorry?
You have an empty buffer.
Wait.
I mean, no text in the editor.
Is my editor not visible?
I can see the editor open, but there is no text in the buffer. I mean.
Oh, okay. 1 second. Is it visible now?
It's the same, just the empty buffer.
Oh,
Yeah, that's weird.
is it visible now? I've exited out of
No,
the editor. Okay. Let me start
I
again
think
then. Is this screen visible?
the screen is visible. Yes,
Okay.
must be because of the bandwidth.
Okay. I'll start a new terminal. Is it visible now?
No,
Oh.
yeah,
How about now?
no, it's the same.
Okay. I guess I'll just talk about it then, since it's not visible.
Uh, yeah, Yeah, I guess that's a good option.
Yeah, okay. So a fuzzy finder is, you can think about it like in VS Code when you hit Control P and it pops up a whole list of files and you can search through them interactively. And then it has some other modern features that you would expect from other editors like git cutters and indent guides and auto pairs, things you would have to install a lot of plugins for in Vim. So these are all provided out of the box in Helix. And it also has language support. So what I mean by language support is that you can expect your completions, your error messages, and all those things in Helix. So in VS Code, if you make an error, it underlines it and shows you the error message. And you can expect the same thing in Helix. It works the same. It works through a protocol called Language Server Protocol, which is something Microsoft introduced to um, streamline and help editors. So the earlier problem was that every single editor had to write integration for language support on its own. So like IDEs had this figured out, but normal editors like Notepad, for example, they could not have these features. So what Microsoft did is define a common standard, a common protocol, which which you can implement in one program, and every single editor which can understand this protocol can get language support for every language that supports this. So I wish I could have done it. It's pretty much the same as in VS Code. You type something, you get completions, you make errors, you get diagnostic messages. It's pretty much the same. And another thing is syntax for navigation and manipulation. So the code we write is not exactly text. It's not. It has a structure. The code we write, for example, a variable has a declaration. A left-hand part and a right-hand part, or a class has a name and then it has a body and a function has arguments. So it's very structured. So what we can do with Helix is select these structures instead of blindly selecting them using cursors and mouses. What you can do is say to the editor, okay, select this function, select the function that I'm surrounded by, or select the next argument of the function call, or select the next class, and select this particular class. And you can do this with maximum of 3 keystrokes. All you have to do, for example, is type MIF, and it matches inside the current function. So that's an example, and this is very useful when you're working with programming languages, because most of the time what you're doing is quote unquote syntax manipulations. So when you change the name of a variable, what you're doing is changing the left hand side of a assignment expression. So instead of selecting the word, you can say select this variable, or select this argument, or if you wanted to change a whole function, the body of a function, you can type MIF, which is match inside function. So it selects only the contents of a function. You don't have to actually go and put your cursor at the beginning of the function, then drag it to the end. You can just type MIF in between any place in the function, and it'll select the inside of the function. So you can think of your code as having actual structure instead of manipulating like normal text. And now coming to some of my experiences as a maintainer of the project and contributing to open source in general. So contributors, I would consider contributors to be a much bigger influence than stars, how much stars you have for a particular project. So a vast number of contributors signify that a lot of people took interest in your project and then took time out of their time to contribute to your project. So that is a much more significant action than starting a repository. So I would always consider contributors to be of much more value than stars. And more contributors mean you have a larger community, and then there is the importance of being a welcoming community. Rust is also a very welcoming community, which is touted as one of its good points. Rust is a very welcoming community. As an example, I'm talking about Rust as an example of this. So when you have a good community, when you have a welcoming community, you can attract skilled contributors, people who know what they're doing, who can understand the goals of the project and contribute meaningfully and help you as a maintainer. And when you contribute more and more and more, you gain more knowledge about the project, and eventually you might be invited to be a maintainer too. That's how I was invited. I contributed a lot when the main maintainer of the project posted a Reddit post. I was learning Rust at the time, so I was looking for a project to pick up. So Helix looked very interesting. I've been using Vim till then, so it looked very interesting, and I sent in small patches, and then I started to work on larger features. And then after some time, I was invited as a maintainer, and I accepted it. And it was a very fulfilling experience, to say the least. It was fun to work on the project, and it's been some time since I contributed, and I want to get back to it. And it's very fun because you're working on this common project with a lot of other people. You share the same vision, you want the same things for the project, and it's very fun to do. And then there's the other side of the coin of contributing, which is reviewing other people's code, which is also a very insightful thing to do because you learn a lot by looking at other people's code. And you also realize how hard it is to actually do it, actually review code, because you have to look through the code and then you have to make decisions, you have to post suggestions, you have to explain things. And one of the things that I appreciate a lot when people send in PRs is how some people make them easily reviewable. So some people send them as small chunks. A larger feature, they'll split it up into small features and they will send them in as chunks that are easily reviewable. And then there are some people who send a single patch, a single commit of 2,000 line changes, and it becomes hard to review them. So it's always fun to review small, to review the easily reviewable PRs, the small PRs instead of the humongous PRs. And some pull requests end up getting big, and you cannot blame other contributors for it. But most of the time, you find some way to split them up into small chunks and make them easier to review, which is something I've come to appreciate as a maintainer, and which is something I try to do now. When I send one example of my post, and not everything on code. Another great way to contribute is to open up issues, to report bugs. And there too, something that I've noticed is the more actionable or the more reproducible the issue is, the faster you'll get a response, for example, from the maintainers. So say if you have an issue, and if you post the steps to reproduce it exactly, and if it's actionable, which means you can do something about it, which means it's not an upstream issue, as in it's not an issue with another project that we depend on. It's actually an issue with us, with the project itself, and if it's actually reproducible, it gets acted on very fast. Contrast this to an issue that pops up and says, hey, this is not working, can you look into this? That's all it says. It just says it's not working. There are no logs, there are no configuration files, nothing. It just says it's not working. That'll probably sit in the issue tracker for a long while before somebody responds to it. So these are some of my thoughts as a maintainer and an open source contributor. So that winds up my talk. So you can find me on GitHub at this URL. My handle is sudo rfbin, and I'm also active on Matrix on the release channel most of the time. So any questions?
Thank you very much for your talk, Gokul. It was very interesting. I have some questions here if you have time.
Yeah, I do have time. I'd love to hear them.
Okay. The first question I have here is, will Helix support plugins at some time, plugin ecosystem?
It's kind of broke off a bit there. I couldn't hear it properly.
Sorry, the
Could you
question
repeat the
was,
question?
will Helix support a plugin ecosystem sometime in the future?
Yeah, it will support a plugin system. Talks are ongoing for supporting this. We first looked into supporting Wasm plugins. Wasm is WebAssembly. What WebAssembly does is you can write your plugin in one language, in any language you want that supports WebAssembly, and then you can compile it into WebAssembly and run it in Helix. So, which basically means
Oh,
we can write it in any language and run it in Helix. But sadly, Awesome is not, um, what's the word? It's not mature yet. It's not a mature technology as of now. You cannot use it directly. So we ditched the idea, and now we are in favor of a Lisp dialect. We are exploring it, so we are writing a bytecode compiler for it. So it will be a Lisp, and we are trying to closely integrate it with Helix, but it will take a lot of time because adding a plugin system is a lot of work. So we expect it to take a lot of time.
yes, that's understandable. You mean
Yeah.
a custom dialect of Lisp?
Yes. Pretty much.
Oh,
It'll be strongly typed, so it'll have a lot of influence from Rust. So we are drawing inspiration from Racket, which is a dialect of Lisp.
yeah,
So it'll be strongly typed and it'll have a lot of influences from Rust. Yeah.
yeah, that's very interesting. Just the other day, I was reading about how you can implement many languages in for the Racket ecosystem, like Type Racket, for example, something like that.
Yeah.
Well, yeah, interesting.
Yeah.
Um,
Yeah.
Well, other question we have here is what were some of the hardest challenges you faced when first contributing to Helix?
Sorry, kind of broke off again. Could you repeat the question again?
Sorry, the internet is kind of wonky. The question
Yeah.
was what were some of the hardest challenges you faced when contributing to Helix for the first time?
For the first time, um, there weren't many non-technical challenges per se. It was very pleasant experience. The main maintainer is very open to contributions. He is very helpful. So my first contribution was renaming some variables, if I remember right. Um, Not renaming variables, refactoring something into macros. That was my first contribution. It was very seamless. It was very easy. There were no non-technical problems with it. It was very smooth. I did encounter technical challenges along the way, debugging bugs and stuff like that. There were no social things there, and I have contributed to open source before this, so there weren't many problems in that sense.
Oh, I see. Okay. Other question we have here is what motivated the difference between the key bindings in Helix versus Vim? Because Helix is also a modal text editor, but the key bindings are somewhat different from Vim.
Yeah, they are different. Helix draws a lot of inspiration from another text editor called Cocoon. We pretty much borrowed the key bindings verbatim from Cocoon. So Cocoon is the text editor that introduced this kind of key bindings. So the primary difference is that in Helix, the order of the actions that you do is inverted. So in Vim, if you wanted to delete a word, you would say DW to delete word. So you say the action first and then you say the selection second. So delete and then word. Or delete and then paragraph. So DP or DW, but in Helix, the order of these commands are inversed. So you specify what you're deleting and then you do the action, or what you're acting on and then you act on it. For example, to delete a word in Helix, you would say WD, which is select the next word and then delete it. Or MIP, which is match inside paragraph, which selects the paragraph and then you press D and it deletes it. So the main advantage of this system is that it's much more interactive, which means you can see what you're acting on. So when you say DW in Vim, you don't know which you do know which word is going to be deleted, but there is no visual feedback that okay,
Mm.
this is the word, this is the selection that's going to be deleted. But in Helix and in Kakon, you first select the thing and then you delete it. And so the main advantage of this is interactivity, and it's much more composable, which means you can build up the selections you want interactively instead of doing it at one go. Which means you can build up a selection. You can select the paragraph first and then select only this particular words inside the paragraph, and then you can act on it. But in Vim, you would have to do it the other way. You would have to say D first, and then you would have to act inside the paragraph and then select them inside, which can get a bit unwieldy at first. Yeah, that's pretty much the main difference.
Yeah, that visual feedback from selection before performing the action can be helpful.
Exactly. Yeah, yeah.
Yes.
And it also
So,
plays good with multiple cursors.
oh, yeah, yeah, that also.
Yeah.
The last question is, if do you have any advice for making CLI tools for the people that are participating in the CLI week this week? Any specific advice or from your experience? What makes a good CLI tool?
What makes a good CLI tool? Okay. A good CLI tool, something that I appreciate about good CLI tools is they're easy to distribute, which means they're, for example, if you're writing something in Python or in an interpreted language, you have to ship the interpreter with the language, and it's not a deal breaker, or it does not make the command line tool the particular command line tool a bad one. It's just that it gets fiddly at times to distribute them in interpreted languages. Um, Also, speed is also something I really appreciate about the command line as a whole. The whole reason I started using the command line was because everything was so fast, so much faster than the GUIs I was using at the time. I had a old crappy laptop back then, but the command line was very fast, and that's what attracted me to it. So fast terminal programs are attracting. So also one thing I appreciate about command line tools. And one thing that I would like to point out is that it would be good if we could make command line tools much more accessible. Accessible as in for visually impaired people, for example. Um, there is an environment variable called no color, which is kind of a standard, which means to disable colors in every single program that encounters it. It's not widely supported, but it's something nice. So if you set the no color environment variable, it means that the program should not use any color in its output. So and other accessibility things, specifics like that. That's also something that I would appreciate to be seen in command line tools. Yeah.
Okay. Okay, perfect. So there doesn't seem to be any more questions. So I guess that's all. Once again, thank you so very much for being here, giving this talk today. It means a lot to us, and I hope you have a successful career, and maybe we can do some activity other day again.
Yeah. Thanks for having me. It was a wonderful experience.
Thank you very
Thank
much.
you.
Have a good evening.
Yeah. Have a good evening.